We've talked about functions in a few ways. There's this basic notation. You've got x and you've got f of x. What that really means is that x is an input and f of x is an output. When we talk about functions, we really talk about there's an input and then there's some process that it goes through to produce an output. And of course, the input is x and the output is y. Let's just use an example of a type that we've seen before down here. The height h of a projectile x seconds after it is launched can be found using that equation there. And so the way that we typically use this is, for example, if we want to know the height of the projectile 1 second after launch, that's h of 1. And I did the math here. And so this would say that 1 second after launch, the projectile is 22 feet high. Well, there should also be a way then that if somebody said, the projectile is 22 feet high, how many seconds has it been since launch? There should also be an equation or a function to find that, to basically go in reverse, to take what would normally be the output, say, hey, here's the output. Can you go back and figure out what the input was? This is what an inverse function does. It takes what would normally be the output and allows you to backtrack and find what the input was. So here's an example. I'll talk about this notation in a second, but this basically means inverse. And so what this is saying is that we can start by knowing that the rocket was 22 feet high, and there should be some equation or function, in this case, the inverse function, where we could put in that 22 feet and we'd be able to backtrack and find out that that occurred at t equals 1 second. And so here, more generally, okay, h of x in this case is given the number of seconds, we can find the height. The inverse, well, would then be, if we're given the height, we can find out how many seconds it's been. Okay, so that's what an inverse basically does. Just to talk about the notation that you'll see, I've got it here, I've got it here. This is not an exponent of -1. This is just a notation that admittedly, it looks exactly the same, but this means inverse. So h -1, that would be read as the inverse of h. Later on in the semester, you'll see like this, that's inverse sine. And the way we distinguish it from a -1 exponent, it's just the situation. This is still written in like a function situation. And so we can tell, oh, that's not meant to be an exponent. That's meant to be showing that it's an inverse. We can just see that because of the situation. Okay, from this little example, where after 1 second, it's 22 feet high, and if it's 22 feet high, then it must have been 1 second. You can see that one thing about functions and their inverses, they undo each other. And so we could look at these situations here and say, okay, if I start out with a height, I do the inverse function, which gives me the time when that height occurred. If I then figure out the height at that time, well, it's got to be the same height I started with, because inverse functions undo each other. This is sort of asking, like, what is the height at the time when the height is 22 feet? Well, it's 22 feet. Functions undo each other in either order. So this is like saying, how many seconds is it when we're at the height that you are X seconds after launch? Well, it's X seconds, however many seconds it's been. Again, this would be like, how many seconds has it been when you're at the height that you achieve 1 second after launch? Well, it's been 1 second then. Functions and their inverses undo each other. So let's move on and start getting some actual equations and functions that we can work with. And one of the first things we want to be able to do with inverses is, given a function, we want to be able to find its inverse. These are the steps here. And the idea is that with inverses, we're reversing the process. We're going from y to x. And so what we're going to do is switch the y's and the x's. And so let me go through this. I'll just follow these steps and kind of show you what's going on. And then I'll give you an example and it'll show why this all works out. I'm going to start, this is step one. I'm just going to start by rewriting this in terms of y. Then we're going to switch to x's and y's. And now solve for y. The idea is we just always write functions in terms of y, and even the inverses still get written in terms of y. Okay, so add 2 to both sides, and then divide by 3. Okay, let's do just a little example. And I think this will help to show what this is and why it works this way. Let's just do f of 4. So we plug in 4 here. 3 times 4 is 12, minus 2 is 10. So when the input is 4, the output is 10. Well, if this is in fact the inverse, we should be able to put in 10 and get back 4. Okay, so let's try it. And by the way, I should probably at this point say, okay, this is the inverse function here, because this is meant to undo or backtrack from this. Okay, so let's try it. Inverse function of 10 equals 10 plus 2 over 3. And it's 12 over 3 is 4. So our inverse function was successful. Our original function took 4 as an input and gave us 10 as the output. Our inverse function was able to start with 10 and get us back to 4. That's what an inverse function does. And we could, again, do this in either direction. We could do the inverse first and then the original. They're inverses of each other, so they undo each other in either order. So let's do this with another one, just a little bit more complex function. So I'm actually going to move this up here just in case I need a little more room. Okay, so we'll start with that first step of just rewriting it in terms of y. Switch x's and y's. And if there's multiple x's, then you just switch them all out with y's. So this will be x equals 4, y minus 3 squared plus 1. Okay, subtract 1 first. Then we'll divide by 4. This is a few steps, this one. We will now square root both sides. So we know what happens when we square root both sides. Plus minus. And then the last thing would be to add the 3 to both sides. So we'll get 3 plus or minus square root of x minus 1 over 4. Okay, what's the deal with the plus minus? Just to explain it briefly. Well, first, any time that we square root both sides, there's a plus minus involved. But why does this actually have a plus minus? Because if we graph this is a parabola, it's something like that, that there are these 2 points at the same height, right? So if we say like f of, I don't know, let's just say this is x equals 2. And here, let me actually label points. Sorry, this will be easier. So we'll do 2, 5, and 4, 5, or 9, 5, whatever. We'll go with 9, 5. So we could say f of 2 equals 5. But if we then do inverse function of 5, there's actually 2 results, right? There's 2 places where there's an output of 5, or 2 different inputs that give you an output of 5. And we're going to discuss this more in a second, but for now, what I want you to notice is just the algebraic process of following these steps. And then, of course, following rules of algebra that we know, like if you take the square root of both sides, there's a plus or minus. Okay, let's move on and find a little bit more. And by the way, we could do the same thing with inputs and outputs and seeing that this inverse function, which again, I'll write this in the form it really should be in, just to show that that is in fact an inverse function. But I could, put in, actually here, let's take a second and do it. F of 2 is 2 minus 3 is -1. -1 squared is 1 times 4 is 4 plus 1 is 5. Okay, so if we do inverse function of 5, we should get 2. Let's see. So 5 minus 1, so I'm down here, 5 minus 1 is 4. 4 divided by 4 is 1. Square root of 1 is plus or minus 1. And so we do in fact get 2. We also get another answer. But we did successfully create this inverse function and then show that it gets us back to where we started right here. Okay, let's do a couple more things with inverse functions. The domain and range end up being important with inverse functions. So the first thing is just to tell you that just as we reversed the x's and the y's, well, that means we're going to reverse the domain and range. So for this first function here, for the domain, since this is a radical function, the thing under the radical has to be greater than or equal to 0. And so we'd end up with x is greater than or equal to -4. So that's the domain. And then the range, this would give us outputs of 0 or greater. We've got the +1. So that'll give us outputs of 1 or greater. And without even finding the inverse function, which we know how to do now, but without even finding it, we know that the domain and range are going to be switched. We know for sure that the domain is going to be x is greater than or equal to 1. And the range is going to be that y is greater than or equal to -4. And we're going to do more with this function on the next page. So we'll get back to this one. I just want to point out that without even finding the inverse function, we already know that this is going to be true. And let's look at another example here. So the domain of this one, it's an x squared. So that's in all real numbers. We can input any value of x to that. The range, the lowest that that can be is 0. It's moving up by 7. And so the range y can only be greater than or equal to 7. And so for the inverse function, I put a g there, we know for sure that these are going to be switched. The domain is going to be x is greater than or equal to 7, and the range is going to be all real numbers. Okay, I said we were going to get back to this one. So on this page here, I've already done a couple of things. This is basically, this is the domain and range that we just did. And then I actually went through here and found the inverse function. You can see I followed our usual steps here. I put this in terms of y. I switched the x's and y's, subtracted the 1 from both sides, squared both sides to get rid of the radical, squared that, that's where this all came from, and then subtracted 4. So, and I'll again write it in our notation here. This is our inverse function. And the other thing I did was I went ahead and graphed our original function. Just for clarity, I'll note here. So this is the original function, f of x. Okay, so that's graphed. And then we've got its domain and range here, and we can tell that that's correct. All of the values of x are from -4 going greater. All the values of y are from 1 going greater. So let's graph this inverse function here, x squared minus 2x minus 3. We've done things like that. That's a parabola, and we know how to graph parabolas. So up here, I started that. I did x equals negative b over 2a to find that the vertex is going to be at x equals 1. And then I plugged that back into this function to find out that the y coordinate of the vertex is going to be at -4. Okay, so let's start putting this stuff in. We've got a point at when x is 1, y is -4. And by the way, this line here is y equals x. This is gonna pop up in a minute as we look through this. And so I could start to graph this parabola pretty easily here. I can find another point here that when x is 0, basically the y-intercept is -3. And so I could start to graph that. And I'm going to make that right side a little more accurate. One more try, because there's this point that I want to make sure it goes through, which is right there. Okay, so reasonably accurate. But there's a problem here. Now, just to take a point here on our inverse graph. So let's look at this point. And I don't know if this is an exact point, but it's okay if it's not. We're just getting the general idea here. This is saying that on the inverse function, there's a point -1, 0, right? Well, that would mean that on the original function, there should be a point 0, -1. Well, that should be there, but there isn't. The original graph is only this. And so we have an issue here because the inverse function is sort of referring to points that don't actually exist on the original graph. Okay, what's the deal there? Well, we talked about domain and range on the last page. Well, this is why domain and range are so important, because the inverse function can only refer to points that actually exist on the original function. If we look at now the domain and range of our inverse function, the domain x is greater than or equal to 1. So this whole branch that we drew over here, that doesn't actually exist on the inverse function because the domain is only numbers that are greater than or equal to 1. Okay, so let's draw the part that actually exists. It's just from here going over this. I missed again. It's just from here going over this way. This half does not actually exist on the inverse function because it doesn't correspond to points that actually exist on the original function. And that brings us to this part. Graphs of inverse functions are the graph of the original function flipped across this line, y equals x. And you can see now these two graphs are perfect mirror images of each other. Whereas when we had this, clearly they were not perfect mirror images. So visually is one way we can tell this. The graphs have to be perfect reflections across y equals x. And the domain and range are another way that we can tell this, that this was not a part of the domain of the function, of the inverse function, and so it shouldn't have been there in the first place. So as we look at this graph now, you could see that you could actually just graph an inverse function visually, that even without knowing anything about the inverse function, you could just sort of draw some points that are like directly across, equidistant across that line, y equals x. And you'd end up with a pretty good graph, a much better graph than that looks like. So we've got a couple of ways to draw those graphs, but this is the big takeaway. The graphs of inverse functions are the graphs of the original function, just flipped across y equals x, and they have to be perfect mirror images with no extra parts or missing parts. And so one way we can do that is to watch out for the proper domain and range. So a lot there. Inverse functions, at their essence, are not overly complex once you get used to them. They undo the original function. And in fact, inverses and original functions undo each other no matter what order that happens in. We learned how to find inverses with these 3 steps. We learned about domain and range, just switch x and y. We kind of saw why that happens with this graph. And we also saw this important fact about graphs of inverse functions, that they are the mirror image of the original one across the line y equals x.